Okay, solving one variable inequalities. This problem's already been worked out for you. We're going to walk through it and maybe highlight some things as we go. So they were solving 2x squared plus 7x less than 15. So you solve it as an equation. So notice they change it to equal to. That's a quadratic, so you're going to need to move everything to one side. Always keep x squared whenever possible. Quadratic formula or factoring, and they got their two. These are called the boundary points. So they put 2 dots on those boundary points. Off to the side, if it's less than or greater than, no equal to bar, you're going to use a hollow dot. You can see in the example, that is why they put hollow dots there. Also, personally, I put the hollow dots above the number line so you can see it more easily. You'll see that in the next examples. If it does have the equal to bar, that means it does include those numbers, you will make a solid dot. Okay, so they put the boundary points on the number line. It cuts the graph into 3 pieces. So then they tested something on each piece. Do not test the boundary point itself, but test anything to the left. So they tested, let's highlight this. They tested the left side by testing -6. Then test anything in the middle. 0 is always a nice number to choose. They tested 0 for the middle, and then test anything to the right, not the boundary point. So they tested 2. Then you can see if it comes out to be true or false. If it's false, don't shade over it. So they did not shade over the yellow section. If it's true, shade over it or connect the dots. That's why the answer is down below. But the green one was false, so they did not shade over the green one either. So only shade or connect where there is a true answer. Finally, whenever they connect like that, you need to write your answer as a compound inequality. So you always go from the smallest number, x is always in the middle, and then to the biggest number, or left to right, if that's how you want to think about it. And the arrows always point that way. It will either be less than, or it'll be less than, equal to, with x in the middle. The only thing you need to check is the original question. Did the original question have that equal to bar or not? This is just a fancy way to say between. The answer is between -5 and 1.5. One more thing you should know. If, let's just say, x is less than -1 and x is greater than 2, let me draw that number line. So if my answer came out to be a hollow dot and the left side was true, and then a hollow dot and then the right side was true, you cannot do that compound inequality for that solution. The only way to write a solution like that is to put the word or in the middle. The between says I can be between -5 and I can be between -5 and 1.5 at the same time. But you cannot be less than -1 and be bigger than 2 at the same time. So you have to write the word or in the middle. That's going to be one of those things where you're going to lose points on test day if you forget to write it with the word or in the middle. So either fancy compound inequality, if it's between, or gap with the word or in the middle if it's or. So let's do some together. First one's written at the top. We've done a few of these now as far as getting the absolute value alone. So start with equal to. Get that absolute value alone first and see if you can find your boundary points. I don't have a ton of room, and we've done a few of these now. So get the absolute value alone first and then unpause your video. Okay, so when you're doing inequalities, you always start with equal to. So you might notice mine says equal to now. After you added the 1 and divided by 4, you should have gotten that the absolute value of 2x minus 17 is equal to 9. Then remember absolute values. The inside, do not change the inside, could equal 9, or the inside could equal -9. So finish getting your 2 boundary points for this one. Pause your video. Okay, so hopefully you got 13 and 4 for your boundary points. So number line, we do not need to see every little tick mark. So what I do is I put 0 somewhere that would make sense. These are all positive numbers, so I should probably put 0 pretty far to the left. I do not need to make a tick mark to 4, just estimate where 4 would be. 13 clearly needs to be further down the line. So it needs to make sense, but I do not need to see every tick mark. Now look at the question. This symbol does not have an equal to bar. So your dots need to be hollow. This is where I do it, above the number line, so that the teacher can easily see their hollow dots to get your full credit. Then we're going to need to test some things. I am going to do number 1 on the next page, so I'm going to just keep taking up all this space. So we need to test. We need to test something to the left. 0 is to the left, so that seems like a good number to test to the left. We need to test something in the middle. 5 is not in the middle, but it's between 4 and 13. And we need to test something to the right. 14 seems like a good number to test to the right. So take some time for absolute value 2 times 0 minus 17. I'll do the first one with you. This is for absolute value of negative 17. Absolute value of negative 17 is going to be positive 17. 4 times positive 17 is going to be 68. 68 minus 1, minus 1 is definitely bigger than 35. This is true. Remember, the alligator math is supposed to be eating the bigger number. That's true since left, right? This was to the left. 0's to the left of my first boundary point. Since the left is true, I draw an arrow going to the left, or shading with an arrow going to the left. Here's the thing. In this class, it will always either go out, or it'll go in. That's the only thing that can ever happen. You're welcome to do those tests. Test 5, you should get false if you carefully test 5. And then test 14, you should get true. But it's just kind of a shortcut. If one of them goes to the left, the other one must be going to the right. And then you need to finish your solution. So notice the solution was not equals x equals 13, x equals 4. We had to keep going and graphing it. The solution is also not just the graph. Now you need to write your inequality. That is x less than 4. There's a gap, so you have to write the word or in the gap. X greater than 13. This whole thing, the graph and the solution, gets you points on your test. Do not forget the solution at the end. Okay, I'm going to copy number 1 down on the next slide. Okay, so solving the inequality. Just like when we were solving them before, start with equal to. I see a quantity squared, so I'm going to want to get that alone first. Add the 1. Square rooting both sides will not do me any good because that's going to give me the square root of x, which I don't want. So do that in an area diagram. Remember, you cannot distribute the square. I know I've said it so many times, but you have no idea how many times students try to do that. X minus 2 squared is x squared minus 4x plus 4. Now I have a quadratic that I need to solve. Always keep the x squared positive just to make things easier, so minus the x. Your choice, quadratic formula or factoring. See if you can finish this. See if you can get the boundary points for this one. Pause your video. Okay, hopefully you got x equals 4 and x equals 1. Now, remember, it was an inequality problem, so you have to graph it. We don't even need to tell you to graph this on test day. The inequality means that it has a graph included with the solution. So that inequality has an equal to bar. So solid dot, again, I do it above so I can see it. Solid dots at 1 and 4. You are welcome to test everything, but remember it's either going to go out, or it's going to go in. So why don't we just test 0 and see what happens? Why don't you test 0 and see if you get true or false? Okay, so when you finish testing 0 carefully, you should get this outcome. Is the alligator mouth eating the bigger number? It is, so this is true. So that means when I tested 0, here's 0, that side came out true. So it's going left, which means the other one must be going right. And then see if you can write your inequality, your final solution. Remember, we don't stop there. As long as you put x first, we should all be working on starting with x anytime we write an inequality. The way the arrow is going at the end of your arrow is the way your arrow is going to go in your inequality. So x is less than 1. There's a gap. Don't forget the word or. Use that arrow trick again. As long as I put x first, the way the arrow's pointing is the way my inequality is going to be pointing. Those are all the x's bigger than 4. They both need an equal to bar though, because these are solid dots. This whole thing is your solution. Okay, number 2 is technically easier than the first one we did. The absolute value is already alone. Split it into 2. You should get 2 boundary points and then unpause your video. See if you can get your 2 boundary points before you unpause your video. Okay, so don't be surprised or freaked out when you get fractions. That's perfectly fine. We just need to know approximately where they are on the number line. Both of my boundary points are negative, so I'm going to put 0 over here. Negative 4/3 is going to be closer to 0, and negative 20/3 is going to be further away from 0. Solid or hollow dots, do you know? The question does not have an equal to bar, so hollow dots, hopefully. Not 0, sorry. Again, it's either going to go out, out, or in. So let's test 0 again. 0 is always the easiest number to test as long as it's not your boundary point. You cannot test your boundary point. Absolute value of 12 less than 8, 12 less than 8. It is not eating the bigger number. So 0's false. So here's 0. If to the right is false, to the left must be true. So this one must be going in. This is one of our fancy compound inequality solutions. You start with the number on the left, the smallest number. It always points this way. X is always in the middle. It always points this way, and then the biggest number. X is between negative 20/3 and 4/3. Okay, moving on to something a little different. We're going to make sure we can use the graphs to answer questions. I know SATs really like to put these type of questions on the test. So there is the graph right there. So this equation is already graphed for us. So this is what we are looking at. Then they want us to find f of 1. So remember, the number in the parentheses represents x. So you're going to put your finger on x equals 1, and you're going to trace or move your finger up, in this case it's up, until you hit the graph. The y value, where you hit the graph, is the answer. So in this case, 3. But I need to erase that so it doesn't look confusing for my next problem. So next problem. That was the answer, by the way. You just look at the graph and get the answer. So f of 0. Remember, this is x. So you put your finger or your pencil on 0, go up or down until you hit the graph. I hit the graph at 4. That's the answer. See if you can finish the rest of these. The top row, please. C and D. Okay, hopefully you got 2. When you plug in 2, the graph hits at y equals 2. And for negative 1, the graph hits at 5. Okay, now notice how they changed. A wants f of x to equal to. Remember, if it equals a number, that's representing f of x, or another fancy word for y, right? So if I graph y, or I draw my pencil, my finger, however you want to look at it, at y equals 2, it hits at 2 points, and those 2 x values are the answer. X equals 2 and 4 for A. I need to erase that for B, though. B, greater or equal to 3. It's still giving me the y value. So a y value of 3. I can see where it hits, but it wants wherever the line is greater or equal to 3. So all of this over here and all of that over there, it is definitely on or above that red line, right? So that is all the x's less than or equal to, my first dot is at 1, or all the x's greater or equal to, that second dot is at 5. C, x equals 4. See if you can do that one on your own. F of x equals 4 at 0 and 6. And then finally, f of x is less than 2. So they give me y. If they tell you f of x is a number, that's your y value, they want all the places where it's less than 2. One thing I should have talked about in the red one. The red one has the equal to bar in my answers because the question has the equal to bar. This one does not have an equal to bar, so my answers will not have the equal to bar. All the points where f of x, the graph, is below the purple line. So from 2 to 4, anytime it's between numbers, that's our fancy inequality, compound inequality. Anywhere between 2 and 4, no equal to bar because the question does not have an equal to bar. Okay, last one from today is a review of kind of the biggest focus, I should say, of the chapter. You know how to do this. We are solving the system algebraically. I will get you started. So they gave you y equals that and y equals that. They want you to solve them algebraically. You set them equal to each other. You're going to want to get that parentheses with the squared alone. You're probably going to have to do x plus 1 squared. Use an area diagram. Don't square everything in the parentheses. That's not how it works. And then see if you can solve for x. So move everything to get the x plus 1 squared alone. Do x plus 1 squared in an area diagram. And then move everything to one side and finish solving for x, please. Pause your video. Well, hold on a second. If I'm trying to get x plus 1 squared alone, that means I have to divide by 2 right now. How many of you are looking forward to dividing 3x by 2? Because I'm not. So instead, since I'm already going to have to do x plus 1 squared, let's do that now. X plus 1 times x plus 1. This is 2 times, that gives me x squared plus 2x plus 1. Because it was going to give me fractions, now that we've multiplied it out correctly, now you can distribute the 2. Now move everything to one side. Keep that x squared positive. Subtract the 3x. Subtract the 2. Now I'm trying to solve for x. So you're still welcome to use quadratic formula. But this is also factoring. This is actually the easiest type of factoring, right? Both terms have an x in them. So GCF, greatest common factor. Take that x out front. Divide. And now I can just do zero product property. X would have to equal 0, and 2x plus 1 would have to equal 0. Minus 1 and divide by 2. So now I have my x's. Did I solve the problem? Do we stop at x? So this question wants the points of intersection. So your answer need to be points. This question had y in it. If the question has y in it, your answer needs to have y in it. So, easiest equation, definitely y equals 3x plus 5, right? I have two x's. I know x equals 0. If x equals 0, y is going to equal 5. So one of my answers is 0, 5. And then I have my other x equals negative 1/2. If x equals negative 1/2, y is going to equal negative 7/2. So then my other point is negative 1/2, comma, negative 7/2. Or you could use decimals. The answer needs to be written as 2 points. A parabola and a line cross at 2 points. You are finding the points of intersection. Okay, that's all we have for today. Again, get help from your teacher anytime you need help. We're always here for you guys. Ask us questions in class. Come to intervention. Send us an email. We're always here for you.